Andrew Cotter, Program Manager for the Cooperative Research Network. Today, CRN's on the road with Valley Rural Electric Cooperative, taking a look at Penn England's dairy farms' animal waste to power technology. Ben Postles is the digester manager who oversees the animal waste to power operations at Penn England Farms. First, tell me a bit about Penn England Farms.
We farm about 2,600 acres of ground. We're milking 1,800 cows. We milk cows in 3 different locations, roughly 50 employees.
Go through how this animal waste to power system works.
We take all the manure from the barn behind me. There's about 750 milk cows there. It gets pumped up to a concrete tank that's actually the digester, and then the bacteria from there takes over. They break the solids in the manure down and give off methane and carbon dioxide. We take that methane and carbon dioxide mixture, run it through a natural gas engine that's connected to a generator, makes electricity, runs 24 hours a day, 7 days a week. So it generates quite a bit of heat. The first place the heat goes is to heat the manure, because we need to heat that manure to 100 degrees to keep the bugs happy. After that, we take whatever heat is left and we pump it up to the milking parlor to help make hot water. It offsets quite a bit of heating oil. Our boiler runs a lot less when we can run heat up to the parlor for washing the milking equipment.
Now, these digester systems, it doesn't just take mechanical know-how or electrical know-how. There's a lot of biology and chemistry involved. Is there a steep learning curve in figuring out the magic brew?
Yes, the mechanical part, I'm kind of a mechanical type person. Mechanical part was the easy part. The hard part for us to deal with was learning the biology. You can't, it's a sealed tank. You can't look inside of it and see what's going on. You've got to rely on temperatures and pH readings and to tell whether the bugs are happy, because if the bugs aren't happy, they don't make methane.
How much do you think you're saving in electricity usage?
Well, last year we generated about $95,000 worth of electricity between what we used and what we sold. Before the digester, we ran a $70,000 to $75,000 a year electric bill. Since then, there's been months that we've had no electric bill.
How much power do you think you produce in a year?
We're coming close to about 1 million kilowatt hours.
Biodigester Technology addresses many environmental issues modern livestock farms face. After digestion, the solids resemble a fibrous dirt that can serve as clean bedding for cows or a fertilizer.
We take all the manure that comes out of the digester, comes into this building, gets pumped up out of a reception tank into the solid separator, squeezes the water out of the solids. Solids come out of it about 70 to 72% moisture. And then we stockpile the solids and use them as we need them to bed the cows.
I think it's quite remarkable. You can hardly smell a thing in here.
Well, this is one of the benefits of the digester. It cuts down on that manure smell. Some people say when they come to the farm, they can actually smell the feed more than they can the manure. And when they walk past the manure storage, they don't even realize they're walking past 4.5 million gallons of manure.
In addition to greatly reduced odor, these systems reduce environmental risks such as soil and water pollution. In fact, it is in the manure management that the farmer finds the greatest value, far more than in the electricity generation. As a result, a majority of biodigesters simply flare the biogas, since the value of electric production is often not economical. From the start, Penn England worked with their local cooperative, Valley Rural Electric, located in central Pennsylvania. Terry Hutchinson, Manager of Engineering and Technical Services, oversaw the interconnection. How is it working with the Valley Rural Electric Cooperative?
Our experience with them has been very good. You know, this was new to us. This was definitely new to the co-op. We took every hurdle that came and just kind of figured out what was the fair way to handle it, and I think it worked out really well.
This was the first one of our members that really wanted to interconnect generation. So it was a learning process to establish policies, guidelines. Penn England Farms was served by a single-phase line. So one of the first things we did was we had a project, a multi-phase, into the farm for stability reasons. So there was, a little bit of a technical issue with that. There's also a trip transfer scheme for protection, anti-islanding with Penn England.
Do you see more of these on more dairy farms in your state?
I do expect to see more of these as nutrient management and the benefits drive the viability of it. Yes, I do expect more.
I'm with Susan Penning, Director of Member Services for Valley Rural Electric Cooperative. Susan, tell me about some of the benefits you've seen from the cooperative perspective as a result of interconnecting this facility.
This has been nothing but a positive experience. It really gives us the opportunity to talk about our commitment to helping renewable projects like this come online.
Have other members start asking questions about this?
Absolutely. We have members call us all the time and they ask for information on renewable projects, and this gives us an opportunity to just say that we are committed to this and that we do have numerous projects in this area online.
Do you have any advice for any other electric cooperatives who might have members and dairy farmers who are asking about this technology?
Well, first, of course, we tell our consumers, research, research, research. Have feasibility studies done at your property. See if this is going to be a viable option for you. So if you're a cooperative and you have a member who says, I think I want to do this, the first thing they need to do is do their due diligence and see if their property would be something that would be an option, because not everybody fits the bill for something huge like this, or even something as small as a couple of solar panels or windmills. They may not see the payback that maybe the vendors or the manufacturers are promising. So what we tell our consumers is read the fine print, have a feasibility study done, and make sure you have clear numbers on what the capability of your particular project might be, because most of the feedback we've got from our consumers has been positive. But if you get a consumer that puts a solar array in or a windmill in, and the manufacturer told them they were going to depend on this much load from that, and they're only seeing a quarter of that, the first person they call is the co-op, the electric company, to say, what's going on with my bill? I was told I was going to offset my electric load by 50 to 75%, and really it's 15 to 20%.
Animal waste-to-power technology has a lot of benefits. It reduces odor, reduces electricity usage, heating costs, and even bedding costs for the animal. But we also learned that it can also be difficult. There is a learning curve. Not only is this mechanical and technical, it's also biological and chemical. Numerous farmers and co-ops have seen significant challenges in operating this technology. Do not expect to turn on a digester and make it work right away. Changes in farm operations can affect the consistency and content of manure. This can affect the system, often days later, making any troubleshooting difficult. In addition, the biogas produced can be rough on many engines. Penn, England, who has a dedicated engineer to run its biodigester operations, has fared much better than many other owners who thought they could operate these complex systems on the side. If you come in with the right expectations and you budget time appropriately, over time these issues do work themselves out and you can end up having a very successful technology. For more information, go to the CRN section of cooperative.com, keyword manure.